Hello, this is our second lecture, and this lecture is going to be on the difference between an expression and an equation, adding and subtracting, basic arithmetic of polynomials. And we'll also talk about what a polynomial is. So to begin with, here I have written an expression. It's an expression because there is no equal sign after it. Okay. So if I asked you to simplify this, simplify means to combine like terms. You can add and subtract only if you have the same exponent. If you have different exponents, then you can't combine them in any way. So here we have a 2x squared and we have a plus 3x squared. And the commutative property says that I can move these around any way I want with addition. With subtraction, if I move it, I have to move the minus sign with it. So here, I can just add the 2x squared and the 3x squared. This is saying that I have 2 of something plus 3 more of the same something. So I get 5x squared. The x squared stays and you just add what's in front. Then I have minus 3x minus 4x, you get a minus 7x. And then the only thing left is a plus 1, so we'll just put the plus 1 there on the end. So we've combined like terms. Now, this was an expression. It did not have any equal sign. An equation has an equal sign. Remember that simplify means you're combining like terms. In the next section in P5, you'll be factoring, which is actually separating of terms. Factoring is the opposite of simplifying, and I did not write my P, so we'll add it there. Simplify. I have an equation I want to solve. You can do the same operations on both sides of an equation. So let's go to a simpler equation, something like 2 equals 2. So if I wanted to change this, I can't just add a 1 on the left side and say, okay, now 3 is equal to 2. If I add it on the left side, I also have to add it on the right side. So adding, I get 3 on the left side is equal to 3 on the right side. Well, it works the same way with variables in there. This is saying that this entire statement on the left is equal to the entire statement on the right. So if I want to try to solve this, then I'm going to move everything around and I would combine like terms. But for right now, I'm just going to show you how to combine the like terms. So we would move the 4x, subtract 4x from the left side, but if we're going to subtract it, the right side, if we're going to subtract it from the right side, we also have to subtract it from the left side. And I'm going to put it underneath of the other term that it's similar to. So then we get on the left, the 3x squared hasn't changed. And then you have 2x minus 4x, so that becomes a negative 2x. And then I have a minus 1, I haven't changed that. And then on the right, I have 4x minus 4x, I get a 0. So then when we get into something like 2x equals 1, well, this is an equation, it has a variable in it. The x is unknown. And we can solve and figure out what x is by manipulating this equation. But whatever we do to one side, we have to do to both sides. And so here I have 2 times x. Well, if I want to get x isolated by itself, then I have to undo this operation that's being done to x. And so the opposite of multiplying is dividing. So if I divide 2x by 2, that's going to cancel the 2 on this side, but if I do it on this side, I have to do it on the right side. So then we get the 2's cancel out, and you're left with x on the left and 1/2 on the right, and that says x equals 1/2, and that's our solution. And we can check our solution by going back to the original equation and making sure it results in a true statement. Well, our original equation was 2x equals 1. If we substitute this 1/2 in where the x was, we would say 2 times 1/2 equals 1. Well, 2 times 1/2 is 1. That does equal 1. So we have a true statement, and so that means our answer was the correct answer. Here we solved the equation. We figured out what x was. Well, often in your homework, you're not asked to solve. You may just be asked to simplify. You're not being asked to solve expressions, you're being asked to simplify expressions. Now we need to talk about what a polynomial is. A polynomial is any expression or equation that has positive integer exponents. An integer is just -1, -2, -3, but we want only positives, so we start at 0, 1, 2, 3, 4. So here, for example, all of the exponents on our variables are positive integers. There are no decimals, there are no fractions. And we don't have to have every power accounted for. We don't have to have an x to the fourth and x to the third. We can skip powers of x. We can have multiple variables, an x and a y in the same polynomial. If we wanted to talk about the degree of a polynomial, the degree is the highest power on any term. Okay, so in this polynomial, we have, this would be a first power. If you have no power written, it's a first power. This would be a second power. This is a fifth power. And so our highest power in any term is 5, so this is a fifth degree polynomial. Now, that's pretty simple, but when you get into having a polynomial that has two variables, an x and a y, we have 3x to the fifth y squared minus 2x to the fourth y cubed plus 3x minus 2. Here, when you're trying to determine what the highest power is on a term, if you have two variables in a term, you add the powers together. So a 5 plus 2, this is a seventh power on this term. And here you have a 4 plus 3, this is also a seventh power. So it's a seventh degree polynomial. Now, if we want to talk about adding and subtracting polynomials. Okay, so now I have two polynomials. This is a polynomial, this is a polynomial. I want to add them together. Well, since everything is added, there's no multiplier out front of any parentheses. That says that we can drop our parentheses. We don't need these parentheses. It was just indicating I have two separate polynomials that I was adding. So when I drop those parentheses, because the addition doesn't have to distribute through. If I had a subtraction, you would have to distribute the subtraction through before you drop your parentheses. But just addition, you can drop parentheses. So now I'm going to start rearranging terms, and I'm going to start with the highest power and see if there are any other terms that have that power. So x to the fifth, there are no other x to the fifths. So I'm just going to rewrite that below in my answer. Cross off that term. Then I have to say, are there any x to the fourths? There is one x to the fourth term. It's a plus 3x to the fourth. Write that down. Then x to the third. I have 2x to the thirds, and I'm going to bring the minus with it. So minus 5x cubed minus another 7x cubed. So these are the same things. If I have 5 of something and 7 of something, I can just add those numbers out front. So here I have negative 5x cubed, negative 5 of something, minus 7 more of the same something. So I get negative 12 of that something. The something was x cubes. Okay, then I look for my next lower power. I don't have any x squareds, but I do have an x. There's only one, so I'm going to write that down, plus x. And then constant terms come last, and so I have minus 7 plus 3, so I get minus 4. Cross them out as you go. Remember to take your negatives with you.